This video we discuss on the basic of thermodynamics. So first of all we have to know what is the thermodynamics. So thermodynamics, it is basically the branch of science where we basically read about the energy and its interaction. So the energy, now we get a particular term that is known as the energy. So what is the energy? Energy basically defined as the capacity to do work. So energy is basically say that the capacity to do work. And here we basically read on the thermal energy, that is known as the heat energy. So what is the heat is basically, we can say it is basically the temperature difference. Heat is basically flow due to the temperature difference. So this is basically known as a heat. তাহলে heat is a particular energy which is basically full due to the temperature difference. And what is the temperature? The temperature, it is basically the hotness or the coldness of that particular substance. So it is basically the hotness or the coldness of the substance. It is basically measured by the degree centigrade of the Fahrenheit. So this is known as a temp. Then we basically get a one particular term that is known as a system. So what is the system? System is basically defined as it is a particular area where the thermodynamic processes take place. The system is basically says that it is a particular area where thermodynamic processes take place. We have a particular system like a closed system, we have a open system, we have and the isolated system. So we have a closed system, open system and isolated. So closed system is basically say that the energy, it is a particular system where the energy and the mass are does not cross this boundary. So this is basically the boundary, and the energy and mass, both of them, not a single thing, cross the boundary. The energy and the mass, nothing cross the boundary. It basically is defined as a closed system. And an open system is basically say that the energy and mass are both can cross the boundary. An isolated system is basically a particular system which is basically uninfluenced by the external environment. So this is known as an isolated system. So we have a thermodynamic processes simultaneously. So we have a thermodynamic process like isothermal process, isobaric process, isochoric process, and adiabatic process, then isentropic process simultaneously. So isothermal process, isobaric process, isochoric process and adiabatic process. And isothermal process, basically the temperature constant. Isobaric process, basically the bar is basically the unit of the pressure. So here actually the pressure will be constant, and isochoric is the volume will be the constant, and as adiabatic is basically the interaction. Here we basically read about the energy and its interaction. So this is the adiabatic process. So the compression, when the compression will be happen, or the expansion processes will be happen, they are basically happen in a reversible adiabatic, that is known as a isentropic process. Isentropic process. So what the expansion process we get, what the compression process we get, that are basically happen in the isentropic process. Then we basically read about the laws in the thermodynamics. In thermodynamics we have like the zeroth law, the law of conservation of energy, and the first law of thermodynamics and the second law of thermodynamics. So the zeroth law of thermodynamics basically say that when a particular two system are mutually equilibrium with a third system, then both these two systems are also thermally equilibrium to each other. So this is called as the zeroth law of thermodynamics. Now if I talk about the law of conservation of energy, it basically say that the energy neither be created nor be destroyed, it only can transfer one form to another form. So law of conservation of energy basically say that the energy neither be created nor be destroyed, it only can transfer one form to another form. Now I came into the first law of thermodynamics. The first law of thermodynamics basically say that if we have a particular closed system, we have a closed system and that particular closed system is undergoes through a cycle, then net heat transfer is equal to net work transfer. So this is basically say that the first law of thermodynamics. So when a particular closed system is undergoes through a particular cycle, then net heat transfer is equal to the net work transfer. But here we have a few limitation over here. So what are the limitation? The direction of the heat flow, it actually the not mentioned, it actually not mentioned. Secondly, upon which condition heat will be flow, that also not mentioned. Here as you see, the direction of the heat flow, that is not mentioned. Simultaneously, the which condition the heat will be flow, that also the not mentioned. So these are the one limitation of the first law of thermodynamics. So overcome that particular limitation, we have the second law of thermodynamics. So the second law of thermodynamics, we have the first one basically say that Kelvin Planck statement. So the Kelvin Planck statement basically say that we cannot make a particular device which basically 100% use the heat energy and convert it into the work. There are always some losses. So yes, it is very practical that when in a particular, if I talk about the IC engine or the engine, normal bike engine, so we have a particular the fins over there. So the through the fins the heat will be the rejected, so there are definitely the losses. So Kelvin Planck statement basically denoted these particular losses. So Kelvin Planck statement is basically say that we cannot convert the 100% heat energy into the work. There are always some losses. So this is basically known as the Kelvin Planck statement. So here we can say the one example, that is a heat engine, we can say that. And the second thing is that we basically say the Clausius statement. Clausius statement, the Clausius statement basically say that we cannot make such a device which basically take the heat from a very low temperature region and transfer it into high temperature region without supply of any external help or without any external help. So this is basically say that the Clausius statement. So if I talk about the example of the Clausius statement, then we can say the refrigerator, our domestic refrigerator, and simultaneously we can say it like heat pump. So refrigerator and a heat pump. So these are, so now we basically talk about the heat engine in our next video. So thank you.